Welcome to our channel Coding Degree. Today we are learning basics of database management systems sem4 degree Osmania University. In this we will cover important questions of computer science 4. Unit 1, Introduction to Database Systems and Relational Model. 1.1 Introduction. In this unit, we will cover the basics of database systems and the relational model. We'll explore topics such as database applications, their purpose, the view of data, database languages, relational databases, database design, data storage, querying, and database architecture. We'll also discuss the roles of database users and administrators. 1.2 Introduction to the Relational Model. In this section, we'll dive deeper into the relational model. We'll cover the structure of relational databases, including the concept of a database schema and database keys. We'll also explore database schema diagrams and the use of relational operators for manipulating data. Unit 2, Database Design and the ER Model, Relational Database Design. 2.1 Database Design and the ER Model. This unit focuses on the database design process and the entity relationship (ER) model. We'll discuss the overview of the design process, the ER model, and how to create entity relationship diagrams. We'll also touch upon extended ER features and alternative notations for modeling data. 2.2 Relational Database Design. Here, we'll explore the features of good relational designs. We'll discuss atomic domains and first normal form, decomposition using functional dependencies and multivalued dependencies, and the concept of normal forms, including 2NF, 3NF, and DCNF. Additionally, we'll cover the database design methodology for relational databases. Unit 3, Introduction to SQL, Intermediate SQL, and Advanced SQL. 3.1 Introduction to SQL. In this unit, we'll provide an overview of the SQL query language. We'll cover SQL data definition, the basic structure of SQL queries, additional basic set operations, handling null values, using aggregate functions, nested subqueries, and modification of databases. 3.2 Intermediate SQL. Here, we'll delve into more advanced SQL topics. We'll discuss join expressions, views in SQL, integrity constraints, SQL data types and schemas, and authorization. 3.3 Advanced SQL. This unit explores accessing SQL from a programming language, functions and procedures in SQL, triggers, and recursive queries. Unit 4, Transaction Management, Database Recovery, and Security. 4.1 Transaction Management. We'll cover transaction support in this section. We'll explore the properties of transactions and discuss the database architecture with modules that handle transactions. 4.2 Concurrency Control. Here, we'll discuss the need for concurrency control in databases. We'll cover concepts such as serializability, recoverability, locking methods, deadlock, timestamping methods, multi-version timestamp ordering, and optimistic techniques. We'll also touch upon the granularity of data items. 4.3 Database Recovery. In this section, we'll focus on the need for database recovery. We'll discuss transactions and recovery and introduce the nested transaction model. 4.4 Security. The last unit covers security measures in database systems. We'll explore computer-based controls such as authorization, access controls, views, backup and recovery strategies, integrity measures, encryption and RAID, redundant array of independent disks. Now let's move into each topics described above. More detailed explanation of each topic along with some example syntax and programs. Unit 1, Introduction to Database Systems and Relational Model. 1.1 Introduction. 1. Database applications. Database applications refer to software systems that interact with databases to store, retrieve, and manipulate data efficiently. Example: a customer relationship management (CRM) system that stores customer information and tracks sales interactions. 2. Purpose of database applications. Database applications are used to provide persistent storage for data, ensure data integrity, support concurrent access, and enable efficient querying and analysis. Example: an e-commerce website that stores product details, customer orders, and transaction history. 3. View of data. Views represent subsets of data from one or more tables in the database, providing a customized and simplified perspective for users. Example: creating a view that shows only the names and contact information of customers without exposing sensitive data like payment details. 4. Database languages. Database languages, such as SQL, structured query language, are used to interact with databases and perform operations like data retrieval, modification, and schema definition. Example: SQL select statement to retrieve customer names from a table called customers. Select name from customers. 5. Relational databases. Relational databases organize data into tables with rows and columns, and establish relationships between tables using keys. Example: creating a table called employees with columns for employee id, name, and department. Create table employees. id primary key. Name varchar 50. Department varchar 50 semicolon. 6. Database design. Database design involves defining the structure, relationships, and constraints of a database schema to efficiently store and retrieve data. Example: designing a database schema for a library system with tables for books, authors, and borrower information. 7. Data storage and querying. Data is stored in databases on disk or other storage media. Querying involves retrieving specific data using SQL select statements. Example: querying a table called orders to retrieve all orders with a total amount greater than $100. Select from orders where total underscore amount greater than 100. 8. Database architecture. Database architecture consists of various components like storage management, query processing, and transaction management, working together to provide efficient and reliable data management. Example: a database architecture that includes a buffer manager to handle data caching and a query optimizer to optimize query execution plans. 9. Database users and administrators. Database users are individuals who interact with the database, while administrators manage and maintain the database system. Example: a user with read-only access to view customer data and an administrator responsible for creating user accounts and managing database backups.